Hey everyone, we are going to be taking a look at our first set of notes for this unit on matter. So we talked a little bit before about how we're going from microscopic to macroscopic, okay? So when we talked about microscopic, we're talking about tiny little particles like the atom, and now we're going to start building it into big things, macroscopic. Okay, and so your objectives today are to be able to take either macroscopic, which are big, or microscopic, which are small atomic properties, and be able to classify matter according to them. Okay, and then once we start classifying bigger pieces of matter, not just individual atoms, but like compounds, molecules, bigger substances, we want to then be able to, based on those properties, make a prediction, or based on the classification, make a prediction about how that substance will act or behave. Okay, so we're going to start off by taking some notes, and so your note sheet looks like this. If you do not have a printer or anything like that where you can use this note sheet, it's totally fine. This is just kind of like a framework, and a piece of paper will work absolutely well. Okay, all right, so we're going to start off with condensing what we talked about when we were wrestling before about what is matter. We've heard this word matter before when we have been going through our science education in elementary, middle school, and we know it means stuff, right? And so, stuff, there we go. But really, when we talk about matter, we want to know what it's made of. What is its structure? What is its properties? What is its composition? And there's two criteria when it comes to matter. One, it has to have mass. So has mass. That's the stuff we talk about. And the other thing is it has to take up space. So these are the two things that are part of our criteria for when we talk about matter and stuff. Okay? All right. Now, we can point to a lot of things in a room and say that's matter. So we've got tables, we've got chairs, we've got people, we've got water, we've got solids, liquids, and gases. But then once we have all these pieces of matter, they're not all the same. They act differently. So this is where the idea of classification comes in. And the reason why classifying matter is important is because we classify matter based on common properties and when we do that, that's important. The reason why this is important is because it allows us to make predictions about new substances, behavior, and property. I'm going to put properties and behaviors. Based on their classification. Okay, so here's an example I give every year about why classification is important. So let's say you're an explorer, and if I told you that I came across a new species, and that species I looked at it, and it had 4 legs, was furry, kind of pointy ears, long tail, jaws, and essentially I'm describing something that sounds like a big cat, okay? And so if I'm an explorer, I see this, I describe it to somebody, they might say, okay, well, that sounds like a cat. And I say, okay, that's great. Can I go up and snuggle it? And they might be like, well, here's the thing. Those types of things also tend to have claws. And if it was a really, really big cat, which it sounds like you're describing, it sounds like it's not going to be like the snuggly type. It sounds like it's going to rip your eyes off with its claws kind of thing. So because those big cats, tigers, lions, and things like that tend to have common behaviors and common properties, especially around humans and other species too, we're able to make predictions that save our lives, that we probably don't want to approach that species. Okay, so that's an example of why classification is important. And especially when we're talking about chemicals, classifying is important because if we come across a substance and it's resembling other substances that are dangerous, we're going to want to proceed with caution. For instance, if I come across a new type of gas and I find out that it's got properties that make it similar to other gases that are really volatile and really explosive, then I'm going to handle that gas with care versus if it's something that is like air. It's going to do very little to my health. I'll probably be fine handling it. Okay? All right. So let's start classifying some matter. Okay? So we're going to create a chart here to help us. And so we're going to start off with this flow chart, starting with matter. So here's all the matter in the universe. Okay, so how do we classify it? We've done a little bit of wrestling with these already, especially with our classification of matter activity. And the first way that we can classify it is into pure substances and, no, this is not going to be impure. It's going to be mixtures. Okay, so now let's break this down. What do we mean by the word pure? I'm going to switch to black here. Okay, so pure means that it has the same composition throughout. Okay, it's the same substance. It's got the same physical and chemical properties. And when I say same, let me clarify for a second. And then it has a specific melting and boiling point. Always. Okay, here's what I mean by that. Let's say that I have a beaker of, let's say, pure water. Okay, so when I say same composition, that means that it doesn't matter if I take this piece of the water or this piece of the water. It is absolutely just one substance, H2O. Okay, so that's what we mean by same composition. It's not like H2O here and H2O2 here. It's the same composition. It has the same physical and chemical properties. So that means that this little piece of water over here is going to be clear and transparent and liquid and everything we know about water. And then this little piece of water here is going to be exactly the same. And then the specific melting and boiling point, well, that means I know this little piece of water right here is going to boil at 100 degrees Celsius, and this little piece of water right here is going to boil at 100 degrees Celsius. Okay, so that's what it means. If I have a sample of it, no matter what piece I take, it's going to be absolutely the same. Okay, now we can break this down even further into two parts. The first one is elements. So elements, those are what you see on your periodic table. So if I take a look at the periodic table, this element right here, zinc, is pure. If all I have are zinc atoms, it's a pure substance. If I have another beaker and all that's in there are oxygen atoms, it is a pure substance. Okay, so elements are considered pure, and what's interesting about them is that they can't be broken down. So if you have just a single element zinc, you can't break it down further into something else. This might make a little bit more sense when we talk about compounds. All right. So here is what I mean by compounds. Compounds would be something like pure water. So H2O is a compound. It's got hydrogen and oxygen, and they're bonded together, so that makes it hydrogen. Or, I'm sorry, a compound. Okay? So compound, these things can be separated. And what a compound is are two or more types of elements that are chemically bonded. Now let me show you what I mean by examples. Okay? An example would be like H2O. H2O, you put hydrogen, oxygen, hydrogen. See how they're bonded together, but it's one substance. And if I have a beaker of pure water, there's nothing else in there but water, that's considered a pure substance, a pure compound. However, I could break these bonds and turn them into hydrogen by themselves and oxygen by themselves, and those would be elements. But I can't break down hydrogen into anything less, or oxygen into anything less. That's like the That's like the last stop. Okay, so that's what we mean by compounds can be pure, a pure substance. But if you used some pretty intense techniques, you could break them down further. Elements, they can be pure if I have a pure beaker of hydrogen or a pure beaker of oxygen, but I can't break them down any further. All right, both considered pure. One can be broken down, the other one can't. Okay, so that is what we mean by pure substances. Now let's talk about the other type of substance, which are mixtures. Okay, now let me just draw my little idea here. Let's say I have a mixture of, let's say trail mix. Okay, so my trail mix could be like some peanuts here, some M&Ms. This one spot's got a lot of M&Ms. Okay, and then maybe I've also got, use green, some raisins, things like that. Okay, so that's an example of a mixture. Another example of a mixture is salt water. Okay, so here's my water, and then there's the salt all mixed in. Okay, let's talk about what a mixture is. So a mixture has variable, and variable means different, compositions. They are not bonded. So pretty much two or more things. So two or more substances not chemically bonded. Okay? All right. So here's what I mean. When I have trail mix, I've got the peanuts, the raisins, and the M&Ms, and they're all hanging out together as one thing, trail mix, but they're not bonded to each other. Salt water is the same thing. When you dissolve salt in water, it's really just the salt hanging out with the water, okay, or sugar water, or things like that. Okay, so here's the difference. If I handed you a glass of sugar water, or salt water, and a glass of pure water, and without tasting them, I said, tell me which one is which, you might not be able to know, because they look the same. So, but trail mix, and let's say a bag of peanuts, I might say, tell me which is the trail mix, which is the peanuts, and just by looking at you say, well, the one with the M&Ms and the raisins, of course. So that tells you that mixtures can be different. Okay, and so the way they can be different is that they can be homogeneous or heterogeneous. Okay, so homogeneous, I want you to think homo meaning one. Okay, so it looks, and the key being looks, like one thing, but it's not. You've got things like salt water or sugar water and things like that. Okay, these are also known as solutions. And another thing that's important about these homogeneous mixtures is that they cannot separate over time. Okay, and what does that mean? I'll tell you in just a second. Heterogeneous, you can visibly see different parts. Okay, so an example of this would be like muddy water. So muddy water, if you really look at it, you can look and you can see the water, you can see the chunks of mud and everything. And then if you let a glass of muddy water just sit there, all the mud is going to settle to the bottom and the top of the water can actually get clear. So that can settle over time, and that's what makes it heterogeneous. Okay, versus homogeneous, you'll mix the sugar water and then you let it sit there and you're not really going to see the sugar settle to the bottom. All right, if it was all dissolved, it's going to stay all dissolved. Okay, so that's what we mean by or something able to be settled or not separated over time. Okay, all right, so here's what we're going to do. We are actually going to, you're going to click on a different link here in a second, but I want you to do this. So you're going to actually do a quizzes, and depending on whether you're doing this on your own or if you're doing this in class, where the teacher will provide you the link, or if the link is already provided with you, what's going to happen is you are going to click on the quizzes link, and there's going to be a substance there. And what you're going to try to do is guess if it's an example of an element, compound, mixture, homogeneous mixture, or heterogeneous mixture. And so you're test your knowledge, like look at what these things are and try to guess. Have your periodic table out too. Now, after you take a guess, you'll see the right answer. What I want you to do is write the answer underneath there. Okay, so let's say you see aluminum and it says aluminum, and you say, I think it's a compound. It says, nope, it's an element. And you're like, oh, okay, let me write that underneath there. Now, there's two things you could do. You can go back and look at your periodic table and say, oh yeah, there's aluminum right there. So it must be an element because it's on the periodic table of elements. Or you could say, that doesn't make any sense. How is aluminum an element? And you could put a star by it. And so when we get together, that's our thing that we need to ask about. Okay? So I'm going to have you pause the video. Or this video is going to stop is what I'm going to say. Whoopsie. And oops. Then you are going to do that activity. Okay? All right.